Okay, we are back again. All right. So on page 427, okay, we're going to look at how do we find the least common denominator of these two rational expressions. Okay. In the video before, we were dealing with whole numbers. Now we have some quadratics in the denominator, don't we? We've got an x squared plus 6x plus 8. And in the other one, we have x squared plus 5x plus 6. And we have to find a common denominator between these two rational expressions. Now, how do we do that? Well, the way we do it is we continue to use our rules. Okay, and we're only going to use rule number 1 or rule number 2 because we are not changing the fraction yet. Okay? All we're learning how to do is find the least common denominator, okay? Once we know how to find the common denominator, then we can change the fraction in order to add or subtract the two fractions, okay? But right now, all we're going to find is what is the least common denominator, okay? So our first rule is we need to factor each denominator completely, okay? Now, if we go back to our earlier studies, we know how to factor quadratics, okay? We factor them into two binomials, all right? So, let's start with x squared plus 6x plus 8, all right? And what is the factor? How do we factor x squared plus 6x plus 8? Well, we are going to have two binomials, okay? And remember, the first factor is going to be x and x, because we have x squared. And then we have to find two numbers that when multiplied together equals 8, but when you add them together, you get 6. Well, that's positive 4 and positive 2, right? Because 4 times 2 is 8, and 4 plus 2 is 6. So that's going to be x plus 4 times x plus 2. And that is fully factored. Okay, I cannot factor x plus 4 any further, and I cannot factor x plus 2 any further. Okay, it's fully, completely factored. Okay, then we look at x squared plus 5x plus 6. And we have to factor this quadratic fully, completely. Okay, we do the same process. We know this is going to factor into two binomials. Right? We're going to have an x and an x. And then I have to find two numbers that when multiplied equals 6 and when added equals 5. And that would be 3 and 2. So we have a positive 3 and a positive 2. Okay? So we have completely factored each denominator. Okay? And these are our factors, okay? X plus 4, x plus 2, x plus 3, and x plus 2. Those are our factors, okay? Now, the next step, so we're just going to be looking at these guys right here. These are our factors. Okay? Then we're going to look. Okay, the least common denominator is going to be the product, the multiplication of the factors, the greatest number of times they appear in any one factorization. Okay, so the first thing we need to do is find what are our factors. Well, what are the different factors that we find in both factorizations? Well, I find an x plus 4, right? So x plus 4 is a factor. So I'm just going to write my factors here. factors is x plus 4. I also have an x plus 2. Okay, that's another factor that we have found. X plus 2. And we have an x plus 3. Okay, so we found an x plus 3. Okay, we also found another x plus 2, but we've already got that as one of our factors, right? So we've found 3 different factors out of these 2 factorizations. Okay, these are our factors that we need to look at. All right, because it's going to be the product of the factors. Okay, so here's our factors. Okay, and it's the product, the greatest number of times they appear in any one factorization. So let's look at each factor and find out how many times they appear in each factorization. Okay, and we take the greatest number that we find. So let's start with x plus 4. What is the greatest number of times that x plus 4 appears in any one factorization? Well, I only see it one time. It's only one time here. Okay? So we have to use this factor. Okay? And that is one time. We only see it once. Okay? Now what about x plus 2? What is the greatest number of times x plus 2 appears in any one factorization? Well, we see x plus 2 as a factor in this factorization how many times? One time. How many times do we find x plus 2 as a factor in the second factorization? I only see it one time. So the greatest number of times that x plus 2 appears in any one factorization is one time. So I only have to use that once, one time. Okay? And then we look at the factor x plus 3. What is the greatest number of times that x plus 3 appears in any one factorization? Well, do we see x plus 3 in this factorization? No. Do we see x plus 3 in this factorization? Yes. How many times does it appear? It only appears once, right? So it's only one time. That's the greatest number of times that x plus 3 appears in any one factorization. So that's one time. So what does it say? The LCD is the product, multiplication, of the factors, the greatest number of times they appear in any one factorization. So the LCD is going to be the multiplication of x plus 4, how many times? One time, times x plus 2, how many times? One time, times x plus 3. And how many times are we going to use x plus 3? One time. So the least common denominator of these 2 rational expressions is going to be x plus 4 times x plus 2 times x plus 3. That is the least common denominator of these 2 rational expressions. Okay? In order to find that, we just use the exact same concepts that we used when we were finding the least common denominator of whole numbers. Okay? We use the same concept in finding the LCD in these 2 denominators. Okay? Hopefully that's more clear for you. And this actually was number 7 on page 427. Okay, this was number 7 on page 427. Okay, and all I was asking for is what is the least common denominator? Okay, that's all they wanted to know. So the least common denominator is x plus 4 times x plus 2 times x plus 3. Okay, all right, so this is the end of second video. Third video, we're going to use this least common denominator that we found, and we're now going to change the fractions, or the rational expressions, into an equal fraction with the least common denominator. Okay? So that will be video number 3. All right, I'll be right back.